Now that we know whether or not a particular value is going to be a solution to a trigonometric equation, what we want to do now is talk about how we're going to solve these equations. What we need to remember is that the trigonometric equations are periodic functions. Therefore, they're going to be an infinite number of solutions to many of the equations that we have to solve. Let's see what I mean by that. Let's go through a problem in which we solve the cosine of theta equals 1/2. If you think about the graph of y equals cosine of x, the graph behaves like this. Therefore, for y equals 1/2, we're going to have an infinite number of solutions. So, the first step in solving the cosine of theta equals 1/2 is finding all the solutions in the interval between 0 and 2 pi. Why? Because the interval from 0 to 2 pi makes up one cycle of the graph. If we look at the graph from 0 to 2 pi, we can see that there's going to be 1, 2 solutions. Let's go ahead and find those 2 solutions. We can find the 2 solutions by drawing a representation of cosine of theta equals 1/2. Well, the cosine of theta will equal 1/2 if the angle theta is in the first quadrant where the adjacent side is 1 and the hypotenuse is 2. But it'll also be the case that the cosine of theta equals 1/2 if the angle theta is in the fourth quadrant. So what we need to do is find 2 angles theta, one in the first quadrant, one in the fourth quadrant, whose cosine is 1/2. Well, in the first quadrant, the angle theta is going to be pi over 3, because the cosine of pi over 3 is 1/2. That would make this reference angle pi over 3, which would make the angle in the fourth quadrant also equal to 5 pi over 3. So, between the interval 0 to 2 pi, the solutions are pi over 3 and 5 pi over 3. However, because the cosine function is periodic with period 2 pi, I can add any integer multiple of 2 pi to this solution, and it will also be a solution. So we'll write that as theta equals pi over 3 plus 2 pi k, where k is any integer. We can write k as any integer as this. K is an element of the integers. Same solution down here. Again, because the cosine function is periodic with period 2 pi, we write the solution 5 pi over 3 plus 2 pi k, where k is an element of the integers. So some of the solutions are pi over 3 and 5 pi over 3. That corresponds to k equals 0. If k is 1, I would get pi over 3 plus 2 pi, or 7 pi over 3, and 11 pi over 3. Because 5 pi over 3 plus 6 pi over 3 is going to be 11 pi over 3. What if k is 2? Then I would get pi over 3 plus 2 pi times 2, or pi over 3 plus 4 pi. 4 pi is 12 pi over 3, so that would give me 13 pi over 3. Here, 5 pi over 3 plus 4 pi is 5 pi over 3 plus 12 pi over 3, or 17 pi over 3. So here's some of the infinitely many solutions to this particular equation.